I get to talk about two of my favorite topics today, which is software architecture and DevOps. But before we start, there's a special occasion I need to address. This is my colleague Frank. Frank is awesome, and it's also his birthday today. So he traveled thousands of miles overseas to be here with us today. And as a birthday gift, I'd like to give Frank a picture with all of his birthday friends here today. So he can share with his wife and his daughter at home. So Frank, can you stand up? So there's Frank. I can't really see him, so can you help me out by all pointing at Frank? So point your entire hand at Frank. He's the tall guy in the middle with the beard. Yes, let's zoom in a little. You may sing, but I'm not going to force you to sing. Thanks a lot for helping out. Maybe better that we do not. So if any of you meet Frank today, this is how he looks like. Feel free to congratulate him. So my name is Bert Schrijver. I'm a CTO at Open Value. I also run the NLJUG, the Netherlands Java user group. And I'm on Twitter at BJ so feel free to follow me there. So for the next 45 minutes, we're going to have a look at a couple of definitions of software architecture. We're going to look at DevOps. We're going to look at why I think DevOps is a good idea that you should or could apply in your projects. We're going to look at the principles or the ingredients of DevOps. And then we're going to basically apply DevOps to the world of software architecture. I'll have a short stint about flexibility in software, and every story needs an end, so this is no exception here. We may have time for questions, but otherwise feel free to come up to me afterwards, and I'm happy to talk during the conference. So what is software architecture? Well, you could say that it's the sum of all decisions you've taken during development. Or that's about making design decisions about important stuff. But then obviously the question is, what's the important stuff? So as Grady Booch says, it's significant decisions that shape a system, where significant is measured by the cost of change. So a decision becomes more significant. I guess my mic is... Okay, I'll try this one. Then you won't see me move too much. So it's where significance is measured by the cost of change. Sorry about that. It's about the choices you can't really revert later or that are really expensive to revert later. It's about enabling a team to build software that provides solutions for business problems. So in the end, we're there to help our business win, right? To make our business succeed. And this is a quote from Dave Farley, the author of the Continuous Delivery book. Software architecture allows you to build systems that are beyond the scale of what you can hold in your head. So with software architecture, you're dividing your system in useful subcomponents that build on top of each other. And any of those components you can keep in your head, but the entire system may be too big to keep in your head. Even if you have a large head like me, it may still not fit. So let's look at a couple of definitions that are relevant for the area of continuous delivery and DevOps. So the first one is continuous integration. So how many of you are doing continuous integration? Can you raise your hand if you're doing CI? Okay, keep it up, please. And put your hand down if not everyone checks into version control at least once a day. So if everybody checks in once a day, keep your hand up. Put your hands down unless every build, every check-in triggers a build and a unit test run. Okay, most people still there. Put your hands down if the build isn't fixed within 10 minutes when it breaks. Oh no, there's always nobody keeping their hands up, right? So definitions matter. Continuous integration is about continuously integrating work, so work from different people in version control, and verifying this by having a built and automated test suite. Then continuous delivery is kind of the next step. This is a way of building and testing software in such a way that it's always in a releasable state. So it's not necessarily deploying everything right away, but having practices to verify that your software is always releasable. Then continuous deployment may be the next step. This is actually putting everything in production automatically. So somebody commits something, your build and test suite runs. Once all the checks are okay, automatically the new version gets deployed in production. So is this the end goal for everyone? I wouldn't necessarily say so. It can help because you're deploying loads and loads of small changes, but for most teams, deploying once every 2 weeks or once every sprint is fine as well. And then DevOps. Well, what is DevOps? It's typically hard to define, right? So whenever I have conversations about DevOps with people, sometimes I get this feeling. We use a word, but what does the word mean? Do we mean the same word or not? It's kind of inconceivable, right? So I'll give you a couple of definitions that I like. It's about devs and ops, obviously, and they are being responsible together, so it's about taking responsibility for the entire life cycle of a product. So it's about being responsible from idea in your head until working software in production. Another definition is to have developers and other IT professionals, and they're working together on a shared goal. And the shared goal is building and running better quality software, quicker and more reliable. So it's about getting software in production. And you get one for free today. So the final one is that DevOps is about a set of practices intended to reduce the time between committing something and the change being placed into production. So it's about having the shortest time possible between having a commit and having stuff in production. Is my mic on? Can I get maybe a hand mic or another lapel mic? Because I won't be tied to the station here. So why should you do DevOps? Well, it's about making your business move faster, right? DevOps enables continuous delivery. It helps you to resolve problems faster and focus on adding value instead of fixing problems. So what is this really about? What's the idea? I'd say that first and foremost, DevOps is about culture. So it's about reinforcing culture with technology and vice versa. It's about collaboration, cooperating, and communicating with each other. About being agile and wanting to continuously improve yourself. And typically this is a culture of freedom and responsibility. So take responsibility, trust your teammates, and design a system in which people are held responsible for the consequence of their actions. But it's not about blaming. It's about taking responsibility. It's not who did it, what we should do next as a team to be better next time. And create cross-functional teams for every product or service. As Werner Vogels, the CTO of Amazon, says, you build it, you run it. So when you're just getting started, this typically turns out into you build it, you ruin it. But I guess that's just part of, becoming better. And it's also about empathy. So empathy is basically being able to place yourself in somebody else's shoes. Yes, thanks. And it means being able to place yourself in somebody else's shoes and know how their worldview is and what helps them. So DevOps also means giving enough about your job to want to learn all the parts and not just your only little world. Empathy allows you to view other teams as enablers rather than as blockers. So my general advice is to be likable, be approachable, and get stuff done. So what are the principles of DevOps? There are loads of principles, but these are the ones that I find particularly important. So it's about making gradual changes, so no big bang releases, lots of small changes. Because small changes are fast, controllable, and when something goes wrong, you're pretty sure that it was in the last small change that you did. It's about being customer-oriented, so focusing on what does my customer want. It's about automating stuff. It's about taking ownership as a team for the service or product you're building. It's about collaborating, so wanting to collaborate together as a team, but also with your end users and other stakeholders. And about experimenting, because experimentation can give you insights that you may not get when you're just thinking about things. And it's also about continuously wanting to improve yourself. So next, we're going to plot those principles on software architecture. So a DevOps team can move extremely fast. And for software architecture to keep up in a DevOps world, it needs to be able to move at the same pace and follow the same principles. So let's look how those principles plot on software architecture. So we'll start with gradual changes, and we apply this principle to the world of software architecture. So it means starting with something simple. The simplest solution that can possibly work that you can come up with. Take that and then start iterating from there. So obviously software needs to be future-proof, but I think it's also fairly obvious that we cannot predict the future, right? It's about identifying high-level components. So which type of components am I going to build and going to use in my system? And then improve and refine along the way. So you're also continuously thinking about your architecture. Did I make the right choices? Is there stuff that I need to revisit or improve? And I guess it's also about focusing on dealing with uncertainty and dealing with risks. So if you're just getting started in a project, it makes sense to think about which things are important, so hard to change, that are things we need to address now. Which risks do we need to address now to make sure that the project at some point will succeed? Or how do we minimize those risks to increase our chance of succeeding with the project? And it's about thinking about the impact of making the wrong choice. So if you make the wrong choice and the impact is 1 week of work to revert it, that may be fine. If you make the wrong choice and the impact is a year to revert it, you may not be too happy. So it's also about doing just enough architecture to get through your next sprint or your next iteration. So I think doing just enough to minimize the risk of making a wrong decision, and also constantly evaluating what I've done. Does this help us, and are we moving in the same direction? In the end, it doesn't really matter how fast you're moving, as long as you're moving in the right direction. If you go really fast but going the wrong way, you're ending up being further from home than when you started. Then look at customer orientation. So it's about focusing on the needs of the business. So typically we as developers and architects, we like to play with shiny toys and do things like microservices and event sourcing and event-driven stuff and cloud and whatnot. But which business person has ever asked you to do event sourcing or do CQRS, right? That's something we do because we love it. But in the end, you're designing for the business and to fulfill the business needs and not your own needs. So you're not designing for yourself. If CQRS is the best solution, arguably, for a problem the business has, by all means, go ahead. So I think one of the places where you can really prove to be valuable is to help with clarifying non-functional requirements. So typically the business will tell you that the system needs to be available and reliable and scalable and secure. And that's fine, but what does it mean? What does available mean? How many nines do we need to have? Does it need to be available during office hours or in the weekends as well? Is 1 hour downtime per month acceptable or not? Scalable, what are we talking about? How many users? Is it 1,000 concurrent users, 1 million? Are we talking requests per second or concurrent users? And availability also, or do we need a multi-region or multi-cloud deployment? Do we need to be protected when Amazon goes down and when we move to Google? It needs to be secure. So what do you mean with secure? Yeah, it must be unhackable. Okay, then maybe find someone else. And they're going to lie to you because they cannot build something unhackable. So it's about helping clarifying those requirements and coming up together with reasonable measures or requirements to fulfill them. And the end architecture is about trade-offs. So if we talk about security versus usability, how many of you love two-factor authentication? Who loves 2FA? Almost nobody, right? Because it's a nuisance. You log in and then you need to pick out your phone or get an SMS or the Authenticator app, but it helps protecting your account. So these trade-offs are something you can also make clear to the business. Okay, if you do 2FA, that will make the app more secure, but it will also be a hassle for people. What if you lose your mobile device and your 2FA token doesn't work anymore? Obviously, a big pillar of DevOps is automation. So if we apply this to software architecture, there are things we can do. So we can use tools to write diagrams as code by using stuff like PlantUML or Structurizer. We can generate diagrams from our source code. So obviously this will only work to a certain extent. So if you have a Java code base, you can generate some diagrams about class hierarchy, or maybe the components are in there, but you're not going to generate an entire architecture diagram. So a typical approach to this is to code your architecture diagrams for a higher level, so maybe a system context diagram, a component overview, and then generate the diagrams for the lower levels. So the plus side of generating is that, well, it's less work, and I'm lazy, so that works, but also it's the only way to make sure that the diagrams are constantly in sync with your code base. So a combination of making easily adaptable diagrams for the higher level designs and generating diagrams from your code base typically works well. You can do automated architecture checks. So there's stuff like ArcUnit, which is basically JUnit tests that can verify architecture rules. Do we not have any dependencies between packages that shouldn't have? Is our package structure correct? Do we only use, I don't know, approved crypto libraries? There's tools like Open Policy Agent you can use to apply policies to your Docker containers. So you can only fetch Docker images from trusted sources. Static code analysis tools that can do security checks on your application. And then there's everything regarding cloud, right? So infrastructure as code to automate your infrastructure, automate provisioning of cloud architecture, auto-scaling. So how does this help us? Because it enables us to design larger systems than we would with only a single server or with on-premise infrastructure. Now let's talk about ownership. So if you apply ownership to software architecture, well, I guess it's important that the team owns the architecture. So the team that's responsible for building and running the application in production should also be responsible and own the software architecture. And as a result, the architect needs to be involved with the team. So you cannot have an architect sitting in a tower somewhere throwing designs down. They need to be actively involved with the team and talk with the team and discuss the impact of the choices they're making. So the architect is accountable for the end result as well. So when the architect is not, this is typically called ivory tower architecture. So somebody is sitting nice up there in the ivory tower throwing things down. But I like to explain this with a new term, and that I like to call seagull architecture. So with seagull architecture, the architect is basically hovering above the developers as a seagull, flying down and looking at the small developers down on the floor. Every now and then the architect dives down, he shouts, "Ah!" and he shits on the developers. And he even steals their French fries and then go back up again, right? So the problem here is that the shit is only going down, whereas in proper feedback loops, the shit should go back up as well. So these feedback loops matter. So whenever somebody does this to you, please explain them the concept of seagull architecture. So it's also about minimizing dependencies to things or teams or organizations outside your team. Because if your team is accountable to get something in production and keep it running smoothly, then your team should also be able to fix things if things are going wrong. So if you as a team depend on another team to do stuff for you or run stuff for you, and I don't know, they break something or they don't do their job correctly, then you're in trouble. So try to minimize any dependencies you have to other teams and make sure that you have everything that you're responsible for under your own control. So this is an image from Gregor Hope's blog. Gregor Hope blogs at architectelevator.com, and he was talking about organizing architecture. And he's basically defining 4 ways that you can organize software architecture in combination with a team. So the first one is the architect decides and goes down to the team and sends their instructions. Architect decides, team executes. So this is typically called a benevolent dictator. So it's not necessarily bad, but there is a problem here. Who sees what the problem is? It's where the thing I'm pointing at. Yes, the shit is only going down, right? The arrow should be going up back again. We should have a proper feedback loop there. So the second one is fine. The architect is in the team, and there's arrows going back and forth. There's active communication and active discussion about architecture topics. The third one can work as well. The architecture work is spread over the team members. So you could call this architecture without architects. That's fine as well, as long as you're sure that all responsibilities are defined. Maybe you split topics over multiple people, or you agree who does which architecture when, as long as you're sure that everything is covered. And then the last one is implicit architecture, basically the inmates running the asylum. There's nobody responsible for the architecture. And this may work for a short time. This is sometimes also called cowboy coding. But I guess, to quote Stefan Tilkov, he said that you cannot decide not to have an architecture. So if you don't actively create it, be prepared to deal with the one that emerges. And that's typically not a pretty one. So if we talk about collaboration, well, it's important that as an architect or somebody who has an architecture role, you talk to all stakeholders that are involved. Maybe the people responsible for the business, people who are in support, people who pay you, and find out what drives them and what makes the project succeed for them. And remember that developers are stakeholders as well, because they're the ones that need to build the stuff that you design. And if you design something that's unbuildable or takes a huge amount of time to build, well, probably you did something wrong. So be transparent and explain decisions and be open for feedback. So I guess one important characteristic for an architect to be successful is the ability to be convinced. You may have thought about something for a long time, and you're ready to sell this to a team, and they come up with an alternative. And it's one that you didn't think of yet. So your instinctive reaction is, as Arun said this morning, to basically to listen to answer, right? You're going to attack and going to convince them that your idea is the best idea. But maybe this isn't. So take time to listen, and maybe take some time for yourself, sit in a room by yourself for an hour, think about, well, is this actually a good idea or not? And then continue. So we talked about non-functionals, and that's obviously important to get as clear as possible, as soon as possible, because this can also have a major influence on the outcome. Especially nowadays with cloud-native stuff and microservices and event-driven systems, I'd say that stuff like resilience is really important, because architecture now is harder than ever, because we keep building more complex and complex systems, because we're building them on a larger scale, and our users keep having higher demands of our systems. So whereas 10 years ago you could say, no, we have a maintenance window every Thursday at 3 p.m. If you do it now, then users will say, why do we have a maintenance window? Google doesn't have a maintenance window. Facebook doesn't have a maintenance window. TikTok doesn't have a maintenance window. And as I said, no room for ivory towers. So if we apply the principle of experimentation to software architecture, I'll do proof of concepts to gain insights. So if you're unsure about something, is this going to work? Is it going to be easy to build, hard to build? Try it out. Do a small proof of concept, either yourself or have a small team work on it, and learn from the insights it gives you. So typically spending 1 hour on trying something out can save you a day or a week of thinking or reverting whenever something goes wrong. And try to solve problems early. So bring those hard things up front in your project and try to work on them as early as you can, because this allows you to steer on your architecture in the right direction and also to reduce risks as early as you can. And embrace failure. So if you can be sure about anything, that things are going to break and fail. So be prepared for things to fail and think about how I'm going to respond. Think about failure use cases for your system. So a typical failure use case is you have an interface with some external system and there's an error there. So if the external system gives you a clear error, like an HTTP response code 500 or 4 something, okay, then you know right away what's going wrong. But what if there's a timeout going on? How does your system respond? Do you have default timeouts set or something else going on? How long is your application going to wait? Are you going to build up queues, go out of memory in the end? So think about those failure scenarios and think how you want the system to respond. And don't be afraid to start over. Obviously not start over your entire project, but an iteration worth of work. So it could be a sprint or a period of 2 weeks. If after these 2 weeks you have the insight that you're not moving in the right direction, by all means stop, throw away these 2 weeks of work and get started, but now start moving in the right direction. So as I said before, speed doesn't matter. It's more important that you're moving in the right way. So this is a picture from Gurgly Oros. Gurgly blogs quite a lot about all types of engineering management topics. And he explained the idea of having RFCs, basically design documents that you share in your organization to get feedback on designs. And somebody asked Gurgly that, hey, you suggested that whenever we want to make a big change, we write an RFC, we share it in the organization, and we get feedback from people in the organization. So he pitched this to his chief architect, and the chief architect said, well, it sounds wildly inefficient to try this out. And then Gurgly responded, well, and he asked, how did it work for you, Gurgly? And then Gurgly said, well, for starters, we did not have a chief architect that would shut down ideas without trying. So experimenting also means experimenting with things that you may not like. But as long as you don't know what the outcome will be, go for it. Sometimes whenever you want to change something in an organization, you get the typical answer from somebody in business saying, okay, that sounds nice, but can you make a business case for it? Who loves making business cases for technical changes? No one. That's interesting. No, I hate it as well. So you can actually turn around. If you want to foster experimentation, you can change the rule and say, I'm going to do this experiment. If somebody wants to stop me, make a business case for not doing this. And then you see what happens. Try it out. So the next principle is continuous improvement. So if you apply continuous improvement to software architecture, it's obviously focusing on those feedback loops. The arrows should be going up and down. It's about asking developers for feedback. What I designed, does it work for you? And does it help you? It's about measuring and monitoring. So the things I designed that will make the application scalable, does it actually help in the response time we're seeing, or in the failure rates, or in errors we see in the logs? So I once had an occasion where I think it was a product owner came up to me and said, I want to remove this feature. No, it was the other way around. We came to the product owner and we said, we want to remove this feature. And he said, no, you cannot remove it because it's used quite a lot. And then we said, well, we're pretty sure that it's not used a lot. He says, yes, it is. So we secretly added metrics that would log how often this feature would be used. And by coincidence, we were also logging user IDs for traceability already. So after 2 weeks, we went back to the product owner and we said, yeah, we're going to remove the feature that's not being used. He said, no, you cannot, because I'm pretty sure that it was used a lot. And I said, yes, in the past 2 weeks, it was accessed 21 times, all by you. So then we could make a decision based on metrics and based on data instead of, I don't know, emotions or vague thoughts. So this helps as well, having those insights to make substantial decisions based on data. And it's also about evolving architecture instead of big upfront design. Because if there's anything you can be sure about, is that the world is constantly changing. And, well, an architect should also be involved in all stages in the project. So obviously upfront a bit to make some significant design choices, but also during the project to see whether we need to steer the team in a different direction, for example. So as a result, software architecture is never finished. There's always work to do. There's always feedback to gain. There's always improvements to be made. And I think this is something that's important to take into account in every project. So I see you think, that all sounds nice, but it won't work in my team or my organization because of reasons. And I already know the reasons that you're going to give me. So this is from a talk by Jess Humble. Jess is one of the authors of the Continuous Delivery book. And he said that reasons that people state why continuous delivery or DevOps doesn't work are, we are regulated, so we cannot do automated deployments. Well, Amazon is regulated and they do a gazillion deployments per day. That's probably even an accurate number. We're not building websites, so it's more difficult for us. Sure, for embedded software, it may be more difficult to have automated tests or automated deployments, but I can assure you that HP is doing continuous delivery with their LaserJet firmware. So if printers can do it, then probably your system can also do it. We have too much legacy. Sure, that may be more difficult if you have loads of legacy code. But there are ways around this as well. There's the strangler pattern, where you wrap your legacy system in a new system and part by part take out things. There's people running Docker containers on mainframes, putting COBOL inside Docker containers. So there's always a way. It may be harder than if you're just building new web stuff, but it's still doable. And then my favorite one. We can't do CD because our people are too stupid. There's a story here. So there used to be there is still a factory in Fremont, California. This is now a Tesla factory. But it used to be a factory owned by the Fremont Manufacturing Company. And around the 1980s, this was generally known as the most, actually the worst performing factory in whole automotive in the whole of USA. Because the management was very detached from the people on the work floor there. The conditions where people were working were bad. They weren't paid properly, they weren't treated properly. And as a result, the employees weren't happy. What a surprise, right? So they regularly started drinking alcohol during building cars. They were smoking marijuana, which was illegal by the time. And they were even doing things like putting Coca-Cola bottles inside doors of cars so they would make a rattling noise if you would open and close them. So this is how bad it was. Must have been fun working there. So then the Fremont Manufacturing Company was going to close down because surprisingly, they were doing too well. And then General Motors, who was just forming like a new coalition with Toyota, that was called NUMMI. And NUMMI stepped in to take over the factory. And then they only wanted the factory, but then the union made them take over about 85% of the troublesome workforce as well. So now they're stuck with the factory and the people who weren't performing before. So they sent some of them to Toyota's headquarters to get training there on lean manufacturing and Toyota way. They gave everybody nice clothes, good working conditions, nice parking spots, and to nobody's surprise, morale improved. And the factory started to become performing and become one of the best performing factories in the US. So after a couple of months, the management of Fremont Manufacturing met up with Toyota and GM, and they asked them like, "So how are things going? Are you keeping up? And are you delivering cars?" And yeah, sure, we're doing fine. Toyota said. So yeah, the problem was the people, right? Said the Fremont management, and Toyota said, "Yes, the problem was the people, but not the people you think." So it was the management all along that was setting a wrong example and not shaping right working conditions that caused the workers to behave the way they did. So if somebody says our people are too stupid, think again, who's too stupid? So actual reasons are our culture stinks or our architecture stinks. And these are all things that are changeable, and they may not be easy to change, but it is doable. So another story about flexibility in software. I joined a team years ago, and they were building software for the government. It was a government project. So I guess it works pretty much the same in the US as in the Netherlands. So there's this thing called tenders, where a governmental organization writes whatever they need, and all companies can say, "I want to build this," and then the cheapest one gets to build it, right? That's basically how it goes. So the company I worked was working this project, and they had a couple of freelance information architects that the government hired to design the system. And their experience was that software was hard to change. So you have people designing software, and their experience was that software is hard to change, which turned out to be a recipe for disaster. Because software is hard to change, so the system needs to be flexible, right? Because if you make a flexible system, then a system becomes easy to change. So they designed the system in a way that pretty much everything was configurable. So every screen you could add extra fields, you could rename fields. There was basically the user interface for the admin interface was more complex than the user interface of the application itself. And then to top it all off, they thought it would be good to have two systems and have a synchronization between those two systems. So if everybody ever starts talking to you about synchronizing data between two systems in two ways, feel free to either grab a stick, run away, or start yelling, because that's typically not a good idea, because of the complexity involved there. What if something changes in A and in B, and you have a conflict, right? That's a nightmare. So when I first joined this project, I was setting up my local environment and, logging into the start screen on the system, and it took like 10 or 20 seconds to load. I think that's odd. This is a simple system, not much data. What's going on? So I asked my colleague, what's going on here? And I said, yeah, there's just a query, database query is going off there, or maybe a couple of queries. So I said, okay, can you show me the query? Because I know a thing or two about query optimization. So he said, sure. So he said, how do you want it? I said, man, can you print it for me? Because then I get an easy overview of how it looks. So he walks off, and I'm waiting. And waiting. And it takes like 30 minutes for him to come back, and he's finally back. And I'm looking at his face, I'm not sure he's smiling or crying, but he's holding a stack of paper about this big. I said, so what's this? What you did? Did you have an accident with the printer? Or no, I got your query just like you requested. So it was 6,000 pages of queries. And the result turned out to be that it was a hot mess of JPA queries, all interrelated, post-construct, post-load, all those things. And then the entire Christmas tree of objects was loaded into memory about 5 times. Because of the complex data model, we needed to fetch loads and loads of things everywhere. And for every drop-down, you could add extra fields, and that would turn out to be a horrible mess. So when we had the first demo with the actual stakeholder, so the person from the government who had ordered this project, he asked, like, how is it going with this and that? And so, yeah, we haven't gotten there yet because it's difficult to build because of all these flexibility requirements. What then happened was both the best and the worst conversation I've ever had. Because he looked at me vague and he said, which flexibility requirements? So I looked at the information architects. They looked away. And it turned out to be that it was something that they had designed because of their experience. There were no flexibility requirements at all. The system was way too complex because this was designed in a way like this. So in the end, we managed to basically save the project by throwing most of it away and building a really simple system. And a really simple system is easy to change. You just change the line of code, you deploy it, and it's changed. So this was a huge, well, turnaround in the project. So as Stefan says, highly specific code is often preferable to sophisticated configuration. So make something really simple, make it really specific, and stay away from any configuration that you may think you may need in your system. So to summarize, how do you work as a software architect in or within a DevOps team? And this is by applying the same principles, the same DevOps principles, apply them to the domain of software architecture. So that's it. Please use your newfound knowledge to go ahead and kick some ass. If you want to do some further reading, I can recommend this book. It's called DevOps, a Software Architect Perspective. If there's any questions, I'm happy to take them now or walk up to me afterwards. Just one small request for you, and that's please rate this session via the Devnexus schedule. Be honest, but also be generous. And just to make sure you know what to do, I'll give you a tip. Thanks a lot for your time. Hope to see you around. Have a great conference. Any questions? There's a question here, yes? Is the deck available? Yes, I'll publish my slides on my Twitter account. It's below here. I'll do it like within the next hour. Thank you. More questions? Yes, there's a question there. Yes, can I elaborate on the last point about specific code for sophisticated configuration? Yeah, so in general, I think that as engineers, we are trained to build, I don't know, adaptable systems and object orientation and apply pattern stuff, right? But I think that in general, we tend to have a tendency to over-engineer and make systems more complex than they should be. So if we talk about sophisticated configuration, it's about having lots of different ways to configure a system, configure business logic. To give an example, like BPMN, if you need to have a GUI to configure flows in your system. Do you really need a GUI to configure business functionality in your system? If it's a simple piece of code that's really easy to change, then probably the business representative can sit next to the developer. They can change the code, test it, and deploy it. Whereas adding like a BPMN system or a configuration or configuration screens may add loads and loads more complexity to make it, in the end, harder to maintain, to change the application. So the simpler your code is, the more easy to change your application is. And often you don't need these sophisticated configuration schemes with GUIs to configure stuff, with BPMN, with properties. Just make code simple so it's easy to understand, and don't add any abstraction layers that you don't need to succeed. Can you repeat the question? I couldn't understand it. Yes, that's a good point. So you add configuration to change things on the fly in production. And this is also a trade-off, right? Because having configurability at runtime, which is basically what we're thinking about, also typically makes your stability go down a bit. Because if you have a configurability that, I don't know, a property that says which class to load for this and that. If you make a typo there, the application won't load. Obviously, you always need some sort of configuration to configure your database credentials or what else. But I'm talking about configuration that allows you to change the functional behavior of your application. Typically, I try to stay away as much as possible from that. Final question? Yes? Oh, that wasn't a question. Somebody just waving. Yeah. Great question. How do you version control architecture? I love that question. What I like to do is to describe architectures in formats that are version controllable, typically text-based formats, right? So if you write your architecture diagrams in a text-based format, such as plant UML or anything else, you can put them in Git and have version control there. If you have a GUI like GitLab in front of it, then people may even be able to directly read it. If you write your architect documentation in Markdown, it's also, you can put it in Git. There are other systems you can use in the end, but as long as you use a text-based format to describe things, I think the biggest thing then is to use diagram generators, because whenever you come into a project and there's an architecture diagram and, well, you want to change it, and you ask, so how can I change it? Yeah, this is just a PNG here, and you need to get credentials for this system to log in there and to edit it and export as PNG and upload the PNG here, and then you're good to go. Well, then I typically stop trying. So make stuff easy to change, and version control helps there, obviously. All right, I think we have a break next, so enjoy the break and enjoy your day. Thanks a lot, and see you around.